Welcome back to the channel. Watch the video until the end, leave a like and subscribe to the channel to support us. We dream of interstellar travel and space conquest, but the idea that we may never be able to leave our solar system can seem daunting. It seems we are stuck on this planet with the prospect that the world will no longer be habitable in 100,000 years. However, there is a solution. We have the chance to survive in the long term and to colonize space. It's a worrying scenario posed by some scientists. In a few hundred years, Earth could turn into a hot greenhouse, with oceans so risen that much of the continental masses would disappear. Imagine an Earth where metropolitan areas like New York, Rio de Janeiro, Hong Kong, and many others have simply vanished. Millions of people would have moved inland, diseases would have wiped out entire populations, the animal world would have become more crowded, and many species gone. Places like Oceania, including Hawaii, would exist only in tales. Cities would be located on mountains that were once considered the highest peaks on Earth. This scenario is considered inevitable if we believe in science. Visionary entrepreneur Elon Musk is one of the first, and surprisingly one of the few, to respond to this future scenario with concrete plans. Musk argues that we need to explore space if we want to survive. One of his ideas is to turn Mars into an Earth-like environment through a process called terraforming, which would involve using nuclear warheads to release water deposits at the Martian poles. Although NASA has expressed skepticism about this specific proposal, it is true that it had considered similar ideas in the 80s but was held back by technical problems, financial constraints, and various failures. Today, Musk and NASA are collaborating through the Artemis project, which aims to create a first manned lunar station in the coming years. NASA will dedicate itself to the scientific part of the project, while Musk will focus on technology and, likely, also the tourism aspect. This lunar station will also serve as a transit point for flights to Mars. However, even Mars does not represent a permanent solution. At some point, even the red planet might become too small or inconvenient for humanity. We should then consider leaving the solar system, but the immense distances pose a significant challenge. The fastest spacecraft ever built by man, the Parker Solar Probe, travels at 700,000 km/h, while Musk's spacecraft travel at about 27,000 km/h. Even at these speeds, traveling beyond the solar system would require impractical times with current technologies. However, the idea of faster-than-light propulsion, once relegated to science fiction, is beginning to be considered by the scientific community. The concept of warp drive, or curvature propulsion, first proposed in mathematical terms by Miguel Alcubierre, could allow traveling faster than light by manipulating space-time. Although still far from practical realization, several scientific concepts are approaching theoretical solutions. Furthermore, current changes in cosmology, spurred by observations made by the James Webb Space Telescope, could open new avenues for physics, perhaps allowing us one day to realize propulsion technologies that do not rely on overcoming distances in a conventional manner, but rather manipulate space-time, allowing us to slip through spatial folds to any place in the universe. The idea of traveling using extraterrestrial technologies might seem like science fiction, but the increasing amount of sightings of unidentified flying objects, UFOs, and reports on hidden advanced technologies could indicate that there are possibilities for space-time travel that we do not fully understand yet. Some argue that the United States military is in possession of UFOs and is trying to reverse engineer their advanced technologies, including those that would allow canceling gravity or traveling faster than light. The issue of Element 115, brought to light by Bob Lazar in the 80s as a key component for UFO propulsion, found a sort of confirmation when scientists synthesized the element, known as moscovium, in the laboratory, although the stable version necessary for propulsion has not yet been achieved. These stories highlight the importance of keeping an open mind about future possibilities of science and technology. The vision of Russian astronomer Nikolai Kardashev, who proposed a scale to classify civilizations based on their ability to control energy, matter, and even space-time, reminds us that humanity is still at the dawn of its technological development and potential. Currently, we find ourselves at the end of stage 1 of the Kardashev scale, where we still depend on unsustainable and harmful energy sources. Moving to stage 2, in which a civilization lives in harmony with its planet, will require significant scientific and technological advancements, as well as a change in our resource management and attitude towards the environment. In the long term, if humanity aspires to become a truly spacefaring and interdimensional species, as suggested by the higher stages of the Kardashev scale, developing technologies that allow us to overcome current limitations, such as those imposed by the speed of light and our ability to manipulate space-time, will be essential. In conclusion, although the challenges are immense, the history of science and technology teaches us that what seems impossible today can become reality in the future. Ongoing research, innovation, and international collaboration will be crucial to overcoming the obstacles that stand between us and becoming an interstellar species. Subscribe to stay updated on videos and articles that explore these fascinating developments and the infinite possibilities that await humanity beyond the boundaries of our solar system.